everyone. Ciao a tutti. Come state? Va bene. Okay, so today I would like to talk about code archaeology. When you work in a complicated code bases, which are quite old, you can encounter many quicksands, many traps, and I hope this talk will give you some insights on how to deal with these traps and how to avoid the quicksands. I started working for Allegro.pl 6 months ago, and Allegro.pl is a web portal that allows you shop anything you want. We have a mobile application for iOS and Android, and everything you want to buy is just a few clicks away from your fingertips. But before I joined Allegro, I worked for a company that developed a chat messaging application. All of the examples I will share with you today comes from my experience while working in this huge and complicated project. I think what's also important to understand before I begin is that this code was probably around 7 years old, and the company which wanted to have this mobile messenger application didn't have resources to build it. So they outsourced development of the solution to external company. The external company had very short amount of time to deliver the solution. They made some decisions for which my team had to pay for. The solution, the trademark for the solution was then bought by my company. We had a license to develop further the solution. But I worked in an amazing team. We used pair programming and unit testing to make our life easier while working in this complicated code base. Before I became a programmer who was really sticked into his job, his computer, I had a different dream. When I was a child, I wanted to become an Egyptologist. Egyptology is the study of the language, history, and culture of the ancient Egypt. Ancient Egyptians had this pictographic representation of their language called hieroglyphs. And as a child, I would write some messages in hieroglyphs, and I would try to decipher them. I would give these messages to my colleagues and friends. And actually, when I think about being an Egyptologist from the perspective of now, I think the job of Egyptologist is not far away from a job of a programmer, because we also have this ancient language called Objective-C. And as a programmer, you can learn how to read it, and you can take certain approach on how to deal with complicated code base and how to navigate yourself through Objective-C code. So I worked in a project that contained Objective-C, Objective-C++, and Swift code mixed together. And we needed to take certain approach of pair programming and test-driven development to make our life easier to develop new features to this messaging application. So today I will dig into what we found when working in a complicated code base. I will also tell you how we preserved artifacts and information we found in a code base. So, when it comes to agile and extreme programming, one of the techniques you can use in software development is pair programming. And we used per programming in the following way. Every day for 17 months, every business day, for 17 months for 8 hours, I would sit in front of one computer with my partner. We would have single workstation with 2 mice, 2 keyboards, and 2 screens connected. And we would solve problems together. We would talk to each other, we would discuss how to approach a certain problem. And this approach is faster than any other development techniques. The math is simple. When you can solve a certain project with one brain, it should be faster if you use 2 brains to solve a single problem. So I met this guy, Ty. He's the one here, a shorter guy. He's Vietnamese, and I would like to say hi to him. Best regards to Ty. And I joined a team with him, and we were working on the UI and UX of the application. So we had this task of updating text for different message types. And we would also have to add another message type. Namely, we would have to create a new chat bubble that displays text based on a message type. And this text would have different properties. During a completion of this task, we had to create a foundation of a new science that we named ethology. So this science allows to understand how switches and ifs work together in a complicated solution. So we encountered the following piece of code. So you can imagine a chat view containing a UI table view and different cells that display chat messages. And this cell would have a method named attributed string for message. It would get a message as an input, and it would output an NS attributed string. And in the middle of it, it would have this switch statement. And this switch statement would contain a lot of different if statements and other switches, because displaying a message was really complicated. And at the bottom of the function, there was this item that did something to the text. It was called attributes painter. And actually, it was painful to look at this code. So what we found inside the switch statement almost led us to doom. In the early days of Swift, you could get familiarized with the concept of the pyramid of doom. And actually, when we're digging through the code base, we're going down through the steps of our pyramid of doom. And what we found there was exciting, amazing, and surprising. So let me rephrase what our task actually was. So what we had to do in the first place was understanding how things worked in this piece of code. We also had to change the existing logic, but we had to do it in a way that wouldn't break things. We encountered a few obstacles. We worked in a very old code base. As Daniel mentioned, the longest view controller had 8,000 lines of code. This code snippet I showed you was a bit shorter. But I think you get a feeling on how the problems complicated could be when we worked over there. And apart from that, there was no documentation for the source code. There were no unit tests. And actually, people who worked on the project initially had left the company. I mean, they weren't a part of our company, but we couldn't contact them, and nobody in the organization knew how things were supposed to work. If you ever find yourself in such a situation, you would ask yourself a question: what can you do? So there are a few options. First of them is you quit your company. You run away from the office immediately and you never come back. But this wasn't what we did. So you can also, every time you have to write a piece of code and you don't remember how the old version of the code worked, you can just delete everything and rewrite it from scratch. But this also isn't an approach that we took. You can also try to understand how things work in a code base you're working on. You can preserve these findings, and you can make your life easier next time you have to write to build on top of the current code base. And this is what we did. Ancient Egyptians had this concept of mummifications, and they saw the preservation of the body after death as an important step to living well in the afterlife. I think that programmers should perceive unit testing as the best way to verify and describe behavior of code as an important step to living well in your life, in their lives. So we took an approach of using code preservation, using unit test to preserve artifacts that we found. When you look at this code over here, you can see that this is a function that takes some input parameters and outputs something. So we can use unit tests. We can prepare some inputs for the function. We put them into this black box. We don't know what it does. And then it outputs something. And we can verify this something. Rephrasing. What we did was we prepared different message types. We then put them into this message cell method, and then we would verify attributed strings we would get at the output. And a simple test, we had a bunch of them, a whole suite of unit tests, and every test was divided into 3 steps: arrange, act, and assert. In the first phase of arranging, we would create different message types based on the params we wanted to test our code for, and then we would extract an artifact after invoking a method on a cell with this message that we prepared in the first place. In the assert phase, we would verify properties on the attributed string we would get as an output. We could check what the color was, what the body text was, and what the font was, and other params as well. And it was also a good idea to shift this logic from a cell to a view model, and this is what we did. We shifted the logic to a view model. Our cell would call methods on a view model, and we were able to build on top of the view model new functionalities. When we were going down through the steps of the pyramid of doom, we didn't encounter any doom because of the unit tests. Archaeology is the study of human history through the excavation of sites and the analysis of artifacts. Right now, I would like you to take to an archaeological dig of a code base I worked in. After a few months of pair programming with Thai, we were shifted from the UI team to the performance team because we're performing so well. And we got another task. We had to improve the cold start of the application. And it means that our application should boot up faster. So we had to find an entry to our code base. There is a method called application did finish launching with options, and application will finish launching with options on whatever implements UI application delegate protocol. So we needed to find one of these two. So this is a snippet of the code we had to work in. I hope last rows can see it clearly. Can you? If not, I will just zoom in a bit. In the app.delegate.m file, we would get a handful of imports. Of course, names are made up, but we had around 100 imports in this file. Then we had some instance variables on the interface of the app delegate. We would have some properties over there. And finally, when we scrolled to somewhere in the middle, we would find the method we're interested in, which is application did finish launching with options. So at the very beginning of our excavation, we found this conditional statement for the unit test UI test run, and it used this UI application shared application singleton, and we were a bit confused because this is application did finish launching with options method. So why would you use a singleton if you get it as an input parameter to the function? You could use it. And I think it's a good point in the presentation to talk a little bit about dependency injection. So imagine you would have to write a class that would mumify a body, whatever this concept means. You can describe your dependencies in terms of protocols. So you can have dehydrating protocol, organs removing protocol. You could use this component that implements the hydrating protocol. You can get the dehydrated body and use this dehydrated body type on organs removing. So you could insert a hook to a nose, and you could pull out brain from a dehydrated body, just like ancient Egyptians did to mummify a person. So if you had this mummificator type, you could inject all the dependencies through an initializer. And in a mummify function, actually, you also inject a body through an argument as an argument to the function. And the output, you get a mummy. And in unit test, you can use these injected dependencies, and you can verify interactions between objects. And it can help you in preserving the information on how your code works and what your code is supposed to do. Maybe this picture will be helpful as well in understanding dependency injection. You can perceive a class as a box, a child toy, and its interface contains different holes of different shapes, and these shapes are protocols. So whatever implements a certain shape, a certain protocol, you can put into this class, into this box. Types that you use in your unit tests can implement this shape, this interface, so we could fit them into the box. And thanks to stubs versions of whatever type that is tested needs, will help you in verifying the interaction in the objects. So we could use the injected application instance, and we could build on top of that our unit test suite. I mean, built on top of dependency injection. Another interesting finding was start of measurements somewhere in the middle of the function. We wanted to measure application called start time. So it was quite interesting that measurement start was somewhere in the middle of the function. So we immediately shifted it to the top of the function. I think you might be familiar with this term. So in our complicated code base, which was developed by external companies, and this code was our legacy, we found code of debatable quality in multiple places. But we wanted to spread positive energy in the team. So we used a different term. So right now, I would like you to be familiarized with other code fragrances we found in the code base. There were comments everywhere, which would describe how things were supposed to work and what they were supposed to do. They could span multiple lines. And they were really helpful. So if you wanted to create an NS locale of English US, what is it called? Identifier, and you didn't know that you were creating an English US locale, you could look at the comment below, which was extremely helpful. Another code fragrance that we found were abusive usage of singletons. So you could find a code shared instance do something, component X shared instance do something else. It was scattered around the code base. And if you recall this digression of dependency injection, we could use dependency injection. We could inject components through initializer or set them lazily. And we could use the injected components also in unit testing suite. So we changed these lines as well. We got rid of all the singletons in favor of properties. And I think it's also important to remember that every time we use user, for example, user defaults.standard or URL session.shared, it's a singleton. We can inject it in some certain way to our code. So we could verify, again, interaction between objects. And the last one, I think it's quite interesting, because dispatchQ.main is also a singleton, and you call a method on it. Usually it's async, but there's also a synchronous version of this method on a queue. And during unit test, during execution of unit tests, you might want to run them in a synchronous way. So what you can do is wrapping this dispatch queue in an abstraction layer. So you can have something along the lines of work dispatcher protocol that has a method called dispatch. And it takes as an input a piece of code that you would invoke on a thread, either background or main thread or whatever thread you want it to be executed on. And you can create an asynchronous work dispatcher that would dispatch these blocks of code asynchronously on a queue. For unit tests, you can create synchronous work dispatcher that would dispatch your blocks of code, your closures synchronously on a queue, and it would speed up execution of your code, and it would be easier to perceive and to understand how it works. Ooh, really? I don't know what I purchased here. Anyway. Yeah, it's important to remember that dispatchQ.main or dispatchQ.global is also a singleton, and you can wrap it in an abstraction layer. I think this is my favorite from the archaeological dig I did with Ty. So almost every component in the code base had a shared instance. This piece of code describes how to create a singleton in this ancient Objective-C language. And a component one type would have perform operations method that has different callbacks to different instance methods, but somewhere in the middle, it was use its own singleton inside, which is very surprising. Of course, you can use self, right? But if you have a function that spans through multiple lines, it's quite difficult to learn that you're actually in the same type and you can use self. So we changed this line as well. So another code fragrance that was quite difficult for us to solve was usage of class methods. And we needed to solve this because we wanted to have expected behaviors tested in unit tests, and it was difficult to test class methods without OCM mock, which is a library for mocking types. So the approach was like this. When we had a class method, we would create a singleton for a type that contained this class method. Then we would change method signature to be an instance method. And then we would create a class method of this that corresponded to this instance method, and it would use the created singleton. Thanks to this approach, we are able to change class method calls to instance method calls on injected dependencies. Another code fragrance were comments to untested fixes, and actually untested fixes, you would have multiple lines describing what a code does, and then you would have this magical line. Can't touch this. Have you ever seen something like that in your code bases? Some people are nodding, so I take it as a yes. So actually, if you can't touch something, maybe it's a better idea to write a unit test for such a solution. This code here touches some UI kit stuff. Again, we had a singleton and we used the application that was injected as an argument. And if we used a mocked, a stubbed version of the application, and we would return something from the Windows method, then we could verify in a unit test that something in this complicated if for if statement actually took place. And we could do it with a unit test. Don't use that, please. So our approach when digging through the code base was, again, preparing some dependencies as inputs for our type. We would test how AppDelegate function reacts through the execution of the code with the dependencies. And in unit tests, we verified interactions between objects. So our sample test, it's quite similar. Again, 3 stages: arrange, act, assert. We create a stubbed version of the application that we inject as an input parameter to the function. And instead of asserting something on artifact extracted from the function, we just verified interactions between objects, between different components. And again, we would have a set of tests for this code, for AppDelegate function. For us, it was a happy end. Our approach of using unit testing to describe how things worked paid off. We maintained the logic that we unearthed through the excavation of the code. And thanks to unit tests, our code was ready for refactoring. So we could get rid of duplicated statements. We could shift some statements to later parts of the upstart process. And our goal was eventually achieved. We improved the performance of the application start. So when you work in complicated code bases, you can encounter a lot of traps. I would like to name a few others that you can find. And I think first of them will be, there are tests that don't actually test anything. And it might be a real scenario, a really common scenario, that you write tests after the implementation of a certain behavior, and you forget about edge cases. So when you actually delete some input parameter from a test, they would still pass for some reason. And this is because people don't use TDD approach, so tests aren't written for edge cases in advance of implementation. You can use many third libraries in your code base. And if they're deeply integrated into your code and not wrapped in any abstraction layer, you could be doomed. So yesterday, an example of parse SDK was mentioned, and developers of this solution just decided that they're shutting down the system. And I worked in a project in which parse SDK was deeply integrated, and it was a quicksand that sucked us into. So wrap your third libraries into abstraction layer. When multiple people work on the same project and they don't talk to each other about their decisions, and the code base is developed through multiple years, you can end up using 3-4 libraries doing the same thing. So you can have a library for networking that is written in Objective-C. Then you can find a library that does the very same thing, but in Swift. And then you can find another library that was built on top of the one in Swift. And you can have multiple libraries downloading some images from the internet. So wrap it in abstraction layers, and remember to talk to your teammates and check if you already don't have dependencies that do the same thing. You can also have a complicated inheritance scheme. So you would have a base class that inherits from type A, then type B inherits from type C, and so on. And when you test the object D that is on the very end of the inheritance chain, some unexpected behaviors might occur because you don't know what these classes in the middle do. So I think it's a good idea to keep inheritance chain very simple or use protocols instead of inheritance. In Objective-C, you can find massive view controllers, but not only in Objective-C. The one that I found with Thai was more than 8,000 lines of code long, but you can extend it even further because you can add Swift extensions to these already massive view controllers. And I think it's important to remember that you can't hide, you shouldn't hide the fact that you use massive view controllers in a Swift extension. Always use another abstraction layer, shift your logic from view controllers to, for example, view models. And I would like to finish with this takeaway, that legacy code is not an old code base. Actually, legacy code is every line of code that you've ever written in your life this is not covered by a unit test. And when you have this perception of what legacy code is, you will feel safer when you come back to the code that you had written, and you will be able to make, if you used unit tests and TDD, you will be good to make changes to your code base in an easy way. So we use test-driven development in my previous company. We used to write a lot of unit tests, and it helped us a lot. And TDD helps in description of your code base and securing it for edge cases. TDD follows this rhythm of red, green, and refactor, which means that first you write a test for a method for your object, what it was supposed to do. Then you make implementation of the asserted behavior, and then you can refactor further your code. And it actually saves you time, but not now, because you need to write additional code right now at the moment when you're implementing the behavior. But it saves you time in the future, because when you come back to the code that you've written 2 weeks ago or 1 year ago, you surely won't remember what it was supposed to do. Unit tests preserve information on how your code works. And they make reality less blurry. When you work in a complicated code base, they allow you to navigate easily through it and make changes to a complicated code base. This picture here shows a sandstorm that ran through Egypt in 2012. So actually, when you work in your code bases every day, if you don't have unit tests, everything is blurry. You can't go through it easily because you have all the noise around and grains of sound, just grains of sand you can get grains of sand to your eyes. And when you use unit testing, things become less blurry as here. So my advice is just use unit tests and make your life, it will make your life easier in the future and things more obvious. So grazie mille. I write on a blog called Swifting.io. If you're interested in code quality, per programming topics, you can find them there, and also other stuff as well. This is my email if you wanted to contact me and to tell me about your adventures while working with legacy code bases. Thank you very much.